Hey everyone, thanks for staying here until the end. So, let's get going. I'm a little behind because of some AV issues, but I guess it had to happen to someone, and it happened to me. So, welcome. First off, let me introduce you to the company. I'm here representing SolarWinds Cloud. This is the title Invisible Reactive Infrastructures because we are a SaaS, and so we provide services that sometimes you might want to do for yourself. Other times it makes a lot of sense to offload it, and we'll be talking about that. This presentation is going to be two parts. One is more the idea, how we got to where we are doing what I'm presenting, and the other part is just going to be a little live demo, hopefully. I was hoping that the repos that I was going to be talking about would be available at this point. They'll be available soon. So this is both ideas and a simple way to try out what we're talking about. So hopefully that's going to be helpful to you also. SolarWinds Cloud is a number of products. We are a family of companies, I would guess, is a good way to put it. I came from a company called Librado. We did metrics and alerting. We are also TraceView. That is now a company called AppOptics. We're also Pingdom. We are Loggly. We are Papertrail, and maybe something else in the future. But we've basically got an SRE team for each product. And so we have Salt deployed as a standard piece of these, some of them more, some of them less. AppOptics, it's part of our standard stack. For everyone else, it's still happening. So this is, this approach that I'm going to be talking about, this thing that I'm talking about, is something I think can also work with other alerting systems and other graphing systems, et cetera. But we use our own system, right? We sip our champagne, eat our dog food, whatever the expression is that you prefer. So that's what I'm going to show you. If anyone is interested afterwards, we could talk about trying to make this work with other systems too, and that's totally cool. So first off, a little bit about me. I've been working at the infrastructure at SolarWinds Cloud for a few years now. We have an SRE team. That's my team. I've contributed a little bit to Salt, made a couple of bugs, fixed a couple of bugs, overhauled the Slack integration, which now needs to be overhauled again because Slack changed their API. All right. So before we get to the end of the presentation, I want to let you know that this is about tooling for human speed and human scale. Some of the presentations here have just been mind-blowing, especially the larger scale ones. The presenters from eBay and LinkedIn are talking about a scale that I can't speak to, which is great. We are dealing with smaller segmented companies, and this is mostly for companies who are smaller and more limited, and I think that's a cool thing. We're more at the medium scale now, but it still works for us. So looking at our very human scale selves, our jobs, and how we want to separate the less interesting parts of our job and have the machines do those is what I want to talk about. I've got these job titles listed just because I have no idea what any of your job titles are. I know I've had a number. But really, the point of having a job title is just so your company lets you do what you need to get done. I want to kind of ignore that. So irrespective of your title, Salt can make your job better, and I want you to be able to do that for yourself, right? Now, time, limited resources, limited everything, but time is the one resource you can't make more of. So let's talk about limited time. When we're a company, when you're working for a company or for an organization, you have a lot of goals and a lot of things you have to do. And your first part of whatever your job title is, the first part of your job is prioritizing what you need to do and figuring out what it is that you actually have to focus on, right? You have to create value, you have to improve, you have to make sure that you get the job done and you know what that job is. And so what we do, like one of the things that everyone needs is you need alerting. And you need the alerts to tell you what's going wrong because your biggest priority is to make sure you don't go down, right? And the alert's the first step in getting you there. You don't know you're down until something tells you. There's so many times when something's gone wrong and the only reason I know about it is because something pings. And if it doesn't, then we have to make sure that it pings us next time so that we don't lose track of it, right? So as I said before, no matter how you get your alerts, I think this approach works. We are going to be using our tools for this. So first thing about starting down this road is kind of have a philosophy about what it is that you're trying to accomplish. Whatever your job is, it results in getting work done in a product. Like the company has a product, you in your job have a product, whether it's software releases, whether it's getting people to their desk faster, whatever it is, you have a product. And so it's deliberate and you have intentions that drive how you do your job, right? Your infrastructure also needs to be deliberate, and the choices you make have to be deliberate. And so it sounds vague, so to make it more concrete, let me ask, like, what do we intend to do? Each time we change something, we have an intention for that change. We don't want it to be accidental. We don't want it to be hit by unknowns. So let's think about infrastructure using the three ways of DevOps, right? We want to improve the entire system. We want to have an idea of what that system is. We want to make sure that what we're doing is going to make it better, not worse. We want to create a feedback loop. We want to have a way to put something in and know what's coming back out of it as well. And we want to enable continuous learning and improvement. I think visibility lends itself to that. Being able to feel confident that what you're doing is something that other people can also build on in your organization. You don't want to be the only person who knows this, right? And so we want concrete, actionable outputs. Now, from there, I'm going to take a side trip into a thing I really like, because friends of mine have presented this in the past, and I think it's a great thing to always think about. So when we're talking about philosophy, let's also talk about framing your discussion. So let's talk about this funnily named thing. It's apparently a Welsh word. It's called Cynefin. And what Cynefin does is it just gives you a way of visualizing, talking about, and communicating what you're doing in your job. How is that? Well, how do I know your job? I don't. How do you know your job? You do. But what you're always going to be doing with Cynefin is you're going to be classifying and discussing the process and the life cycle of the things that are challenging you, right? If you didn't have a job, you wouldn't be challenged, you wouldn't be using Salt. But here you are. You do have a job. The job is going to challenge you to do things. And that challenge is generally about taking things that no one knows about and figuring out how to discuss it and how to make it easier and more tractable. So think of it this way. When you have a new and different thing in this lower left quadrant, something brand new, whether it's a bug or a feature or just a random event like a hurricane, it's chaotic. You don't know what it is, but you might be able to control something, right? So you figure out where those lines are drawn, but anytime you do something with it, it might break. And then what happens from the chaotic phase, you try to move it up into the complex realm. Complex just means, well, things may still break. It's not 100%. It's not perfect, not even close to perfect. You don't even know if what you put in you're necessarily going to get out, but you might be able to start drawing some lines and finding a way to say, okay, I understand it now. I've gone out to the community. I've gotten feedback. Someone's told me that they're familiar with this and given me some guidelines. Now I understand it a little more. Then the next step is we want to get from complex to complicated. Complicated means, well, I now have an emerging notion of what's supposed to happen, and I can start really, really working with this, and maybe I can even start resolving it or providing myself with the tools and the conversations that will actually lead to resolving it. And the last step is obvious, and obvious is when you've gone from French chef to McDonald's, right? There's the burger on the one side, and then there's the 2 minutes on each side, and it's out on a bun, and everyone knows exactly what the steps are. Everything is described. You no longer have to think about it. Now, there's the little thing in the middle called disorder. Most of us try not to live there, but there are parts of our jobs that do. That's where you can't do anything about it. It's important to have these ideas in mind, because if you can discuss it with other people, you can say, hey, this is never going to get fixed. It's in this disorder realm. It's not going to happen. We'll try to do what we can about it, but it's happening. And in these other realms, it's nice to say, hey, this is complex or this is complicated. We don't quite have a way to work with this. We have some ideas, et cetera, et cetera. But it gives you the ability to discuss the problem you have and to let everyone understand how confident they should be that you have an answer, a next step, a way to progress, et cetera. And yeah, I think calling back to Mike Place this morning, one of the keynotes, this is a way to embrace the chaos, right, and to make it a little more controllable, is to start by thinking about it and having a common language for discussing where you are in your resolution. So back to philosophy. Our general philosophy, and this is, again, believe me, leads to concrete solutions, but the solution part is short as a demonstration, so I want to discuss this because I think it's more important. We want to make this human scale. The people are important when you're creating an automatic resolution, because the people are the ones who are ending up looking at this, verifying, and making sure that as we move that process through that Cynefin kind of hopping over the fence, people have to be doing this and people have to understand it. This means that we want our automation to do what a person would, the way a person would, just without a person having to do it. So pretty much everything we think is a distributed system. Salt is a distributed system. Your database is a distributed system because you're going to hit it over the wire. Your customers are hitting you via a distributed system. And we create these beasts constantly, and so we need to be aware of what we're doing, and we need to build our resolutions to be very sensitive to that. Now, thinking in terms of Cynefin, our philosophy is to move chaotic to complex, complex to complicated, and if things go really well, we can even make it obvious. But there are different things you can do in each quadrant. And that means maybe just describing the problem to the person who's going to solve it. It means making it visible what has to happen next. And another important principle is don't automate what you don't understand. Don't try to make the computer do things faster just because it's faster. Try to help it give you a clearer picture. And in the end, you can make things that are very complicated, and then what we want to use Salt for is to make that easier to operate. Again, for a person and eventually for a computer. So a little more about our philosophy is that distributed systems break. Distributed systems break when you configure them, when you try to do things automatically. Until you're really certain about it, you want your distributed system to be operated on by a person or with the care a person would give. You want to make it similar to how people deal with it. That sense of caution, that sense of fear should be there. There are things in your configuration that can change, but there are things that are more on the distributed side. You have a lot available to you with Salt, though. You have all the information you could possibly have as a person. Salt can tell you that, too. You can know about regions. You can know about hosts. You can know about processes. You can know about the ring, the rack, all of these other things that go into configuring distributed systems. But all this information, even though it's presented to you the same way, it can't be acted on the same way. Things that are distributed, you have to be more careful about. And so we've developed a certain set of guidelines for ourselves. We run high states constantly. We want a certain part of the system to always be in sync and to always be reliably taken care of. We want high states to configure the host, though, not the applications. Whether it's an internal application or something we run from the external, we don't want that to get reconfigured and then potentially go down and come back up in a state where we haven't tested it out. We don't want it to get restarted automatically either, because things that provide consistency to your network don't like it when you treat them inconsistently. Now, high states install software, high states configure the host, but high states never write application configuration, and high states never restart a service. To bring up a system, after the system is ready, after the high state is run, humans run the configuration, humans run the restart, the start, the joining, until we have a huge degree of confidence that it can be done automatically. I want to stress to you, I can't tell you how many times I've seen people try to take it from zero distributed system, from brand new zero to it should be fully automatic and no one should have to interfere with this, and not realizing that 99% of the actual work is in that last one bit. And if you just have a person do it, your life is better and you have less to deal with. So the next thing is you always want to expect change, right? Everything changes, even if it's not when it's not official or planned or expected. Nothing is ever going to be 100% stable. And so think about the failures that you expect. Think about them in advance, even before you have to remediate them. When you first hit that failure, you should have an idea, hopefully, of the class of failure it is and how you want to respond to it. And also, once you do know that, then you can begin automating it. And make your future self happy as you think about these things. Document them for yourself so that the groundwork you lay, you and your team, can rely on that in the future. Now, once we've started building stuff, we need to make that work visible. I keep talking about that. What does that mean here? There's a lot right now in the monitoring space about observability, visibility, logging, and I'm not talking about that. I'm just talking about making sure that what you do tells you and your team what you need to know. We have a returner in SaltStack right now. It's in the development branch because we just updated it from our older Librado returner. But we have a returner that lets you graph out how many states have succeeded or failed. It also lets you tag not just high states, but specific states. So if you want to watch something more carefully than others, you can graph it and you can alert on successes and failures in those particular state calls, which we think is a good way to tell yourself whether you're working. And we also want everyone to know that there's changes, right? This is a way to say, success or failure, it's better for everyone to know. And when things do fail, we also like having a mechanism to tell us in chat, because that's actually where we live. We'd like to believe when you have graphs that everyone's looking at graphs, but once you start with graphs, they multiply, and you can't actually watch them all. You need things that you need your alerting system to tell you what's wrong with the graph. And as long as it's doing that, you might as well have it tell you a little more in chat too, because that way you don't have to take extra steps to diagnose it. Now, a word about that. I'm talking about the machines, I'm talking about people, I'm going back and forth. We want things to react at a human scale, right? People operate things, so even if you automate it, you want a person to be able to invoke this, and this is another place where Salt is strong. If you construct things as states, if you construct things as runners, as execution modules, then people can run this and then the computer can run it via an API, and it's much, much more powerful that way. So the goal is to do this and keep in mind that when you run a remediation step, a person will be able to look at that and say whether it ran, how long it took, and does it need to be done again? Was it the right move? Maybe you need to disable it, but the person is the person who operates it at the end of the day. Now, once you've gotten that whole philosophy, that whole idea in your head, the first thing you have to do is do your crawl, walk, run cycle, right? Take things from chaotic, your first steps, towards a more ordered resolution. And so the first thing you want to do is figure out, is there a state I can run? Is there a command I can run? Is there data I can get? And can I use something that will feed that data back to me? Again, we like graphs, we like logs, but we also like chat. We also like the command line. So whatever you need to do, get a first step to start giving you more information. The next step is your walking steps. You have your first views of it. You've created your first states. You want to start being able to put them together. You want to say, hey, I need this information about the host, this information about the network, this information about what's happened over the last 5 minutes. Find those data sources, put them together, and present them to yourself, right? Have that information to further along your thinking about the problem. Then lastly, run and figure out. If you get it to the point where you know what the problem is, you've narrowed it down, create an alert for just that specific problem. And then if you can run that command from a command line, well, why don't we just let Salt do it, right? If you can fix it, even if it's multi-step, well, there's nothing else you have to do, right? It's that easy, except for the fear. What happens if I do it wrong? What happens if I take everything down, right? It's bad. So let me tell you, what we do is we do alerts, right? And our alerts come out as a graph. And when we do this, we like to say, okay, we have data, or maybe we don't have data. There's a threshold that's been crossed. We don't have a threshold that's been crossed. And it stops alerting when that threshold is good. This is bog standard. This is what everyone expects from an alerts, right? Everyone expects this. It's not outrageous. Is it? Okay, well, this is what you should expect. And what happens is you should be able to look at your infrastructure and say, oh, there's something wrong. But again, you don't spend all of your day looking at these things, right? You should be alerted by it. And so we have alerts. And these alerts, we put together dashboards and we say, hey, I want this to become an alert when it hits a threshold. This is what it looks like, et cetera. We're a cloud-first AWS shop, and so we think that the way to tell Salt about this is via a queue, because we're not in your infrastructure, and we don't want you to expose your infrastructure to us except via a constrained method. And in fact, we like it. It makes it better to not expose Salt via a webhook to the outside world. And hey, maybe when you scale, maybe you'll have some of these problems like eBay has of how do you trust your users? Well, maybe you trust them through a queue for this particular kind of thing. I don't know. We haven't gotten there yet. Now, I feel strongly that another thing that's good about a queue is that it's a lot more like the way a person works, right? We put things out one at a time. Remember in our philosophy, the person operates it. And so when you see the events that are coming through, when you're performing your remediation, when you've automated your remediation, you want to see those events as a story that you can replay for yourself, because maybe you have to do it manually for yourself. Or maybe you just want to make sure that each time you see it, if something's changed, you'll notice it. The story should be laid out clearly in whatever methods you use. Now, what a queue does for us here is it prevents flapping. A queue means it works the way a person does, and it prevents things from happening so quickly. It makes it trivial to prevent things from happening so quickly that you don't know how you just fell over. It means that once one thing gets run, another thing gets run, and it tells you about it. And that's super important. And that is getting a little ahead of myself, because why don't you use a reactor for this? And that's because reactors can go super fast. And in the case where you're afraid that you might be manipulating your infrastructure programmatically, fast is your enemy until you're very, very sure that what you're doing is trivially harmless. So, like I said, we want to slow down. We want to take our steps, we want to put them together, we want to be able to run them, and we want to be confident about them. I really wish there was an advanced reactor, a complex reactor available in the free version, but that development has stopped. That would actually make some of what I did a lot easier, but the principles still apply. So when we first got going, I should say, when we first got going with this sort of an idea, we did it in AWS, and we said, hey, some of our instances disappear. We don't use auto-scaling groups for everything, and we don't just want to rely on things like, we don't want to rely on someone noticing it going down. And our biggest fear was literally, well, what happens if one day CloudWatch decides to tell us all of our systems have disappeared? Has anyone thought through this before? Something similar? What happens if it's not our fault? What happens if we're just given bad signal? Having things in a queue mean that we can't destroy everything at once. We can destroy some things, but we can also try to limit ourselves, alert ourselves, and be better about it. So I think that for a smaller shop, serializing and slowing down is super important. It's like with Agile, sometimes you have to go slow to go fast. This kind of going fast is finding more resources for yourself, letting you get your work done while the computer does the things that you don't care about, making a better job for yourself. And at the end of the day, we log, we put things into chat, and we let the computer tell us when we're done, because we can say, hey, this node, what's going on? It's recovered. Oh yeah, here we go. It's all good. Move on. Now, I have a demo here, and this demo is sort of trivial, but I think it's kind of fun. So let me mirror my screen so you can see it, and then we'll take questions afterwards. I think I'm still a little ahead of time here, so, I mean, I'm not, my delay hasn't made it so that there will be no question time. So, just a minute, let me mirror my screen here. Woohoo. Oh, and you know what we're gonna do here? That's right. Yes! Some hold music while we get this going. Genuine elevator music. Where'd the screen go? All right, so what I have right now running, I'm going to show you the build up here. I have a chat room where you can see I've tested this before. I have a state of 3 systems here that I can look at. This is actually the less nice graph. Let's just look at these, and actually let's look at that. And let's actually look at this from the question of how Zookeeper thinks. Oof, nope, I should have tested that before I did it. Let's just go back to the generic here. Here are some logs for the Saltmaster, and here's the presentation. All right, so what I've got here is a 3-node Zookeeper cluster running in VMs. So let me, oh gosh, you know, when I restart I was gonna do this, but let's not. Woohoo, winging it. So let's just SSH into the Saltmaster, and let's SSH into one of the minions. Now, what I'm going to be doing is I've got a runner. So the package that I put together and the actual practice of what we did is that every single thing that this engine that I've written will do has to be activated via Salt runner on the master. The master has access to the entire environment, and so the master can make decisions, and you can make decisions via the master about what sorts of remediations you're going to want. Now I'm going to take a trivial case, or a relatively easy case with a not-so-trivial system, which is Zookeeper. Everyone here used Zookeeper or Console or etcd or anything before? All right, cool. So it's a consensus thing, and the consensus gets a little messed up when you get down below 1/2 of your systems. So it's super important with Zookeeper that you know if any of the nodes have disappeared. I mean, really almost anything we run, it's super important that you know that they've disappeared, but some of them you can leave until later, like if you have a web farm and one goes down, If Zookeeper 1 goes down, you start sweating. So we're going to sweat. Now, the first thing I need to do, though, is I need to go to Etsy, and I need to say, hey, salt master. I want to look at this runner. Oops, nope, I want to look at this engine. And this is kind of ugly because Salt rendered this out for me. But the basic idea, the thing I want to call out here is this. I have a little runner that I call Zookeeper. And so let's do this. Let's stop this. And, very important, alerts should never fire too quickly. All right. And what's going to happen here is we're going to find an alert fire. I created an alert, and that alert tells me, most of the time, we were at 0, and most of the time we have 2 followers, which we should. Oh, that's just killing me. Sorry, everyone. So let's actually just look at our metrics. And we're seeing it. There we were. Now what's going to happen is we have an agent on here that's sitting there asking Zookeeper, basically, if you're familiar with Zookeeper, there are the 4-letter words, the ones that say, are you running, is it working, et cetera, et cetera. So it's the way you would monitor Zookeeper is you ask it about itself. And for us, we like to make it a little easier, and so we say, we wrap it up as a little module, so we can say, hey, look, oh no, they're all not running. I'm silly. I forgot to start them to get this going. Again, I had this all prepped and then I had to reboot the system. Sorry about that. Now it's going to look a lot better. See? They're all up and running. Now let's stop this guy again. I got too enthusiastic there. Now what we're going to see is after this big blank period from when it ran, when I unlocked my laptop to the data now. Our alerts do alert on absences, but I did not tell it to alert on absences because most of the time while I've been here, my laptop has been closed. That would be an absence. So right now what we should be getting is that this is saying that there was a leader. The leader was at 1.1, and at one point it was 3, and it's telling us that each time it had 2 followers, and that's good. That's the desired state. And I have just, of course, destroyed that, and I've said, here, my error comes out as connection refused, and because I have a result false, sort of similar to the way the high state returner returns things, I can actually say when I'm running things, something broke in this process. This process should always be working, and pretty trivially, the engine underneath this, when it goes to resolve it at the end, it can know whether everything has succeeded or not because I have the return format defined. Now here is bad. This is 1. This is Zookeeper telling us that it's not healthy. It doesn't know that. The leader knows that. And it shared that information with us. Now what's going to happen here is that I've got 3 versions, 3 little iterations of this runner. Whoops. And the first one is sort of the crawl phase. And it's actually going to do something interesting, and I'll point it out. Oh, fun. Yay, it broke. I just got an alert. I just got an alert. This is what I want to hear. I want to know. But this is funny because it's telling me something went wrong, but it's also telling me, wait a minute, you can go. Well, I just did something wrong here, and this is an interesting case. What I was alerted from was the perspective of the leader. And the leader is clearly running because it alerted me. Well, that's a thing that happens a lot when you have distributed systems. You get confused between the system you're working on and the entirety of it. And so you can use your knowledge as the next phase, which to say, you know what, that's a problem. I am not getting good signal out of this thing that I'd set up, so let me fix that. And so the next part of your life will be figuring out at what resolution to deal with this. Now, the way this engine is written, Salt only reconfigures itself, the Salt master, when you restart, as far as I'm aware. But this does reread the configuration file. So essentially a live reload. So if you had this configured via high state and ran a high state, it would reconfigure it. The next time it ran, it would rerun this configuration where I'm mapping a specific alert to a specific runner that should resolve it. So now it's saying, uh-oh, what happens? Now that I've changed that, now it knows what's up. That's what we want to know, right? Now I know it's failed. It's not just telling me everything's happy. It's not fooling me. Now I know I'm broken. what do I want to do about this? And what I really want to do here is I want to say, well, I have this thing that says I can check all the nodes and see if they're good or bad. Well, that's easy. It presents itself as data because that's how I wrote it. It doesn't have to, but you have to, think one step ahead. And if you're ever doing a presentation, don't try to figure this stuff out on the stage, right? So here I am, and I have a third phase of this, right? And this third phase, what this third phase is doing, this is not too bad. I was afraid these default colors would be really terrible. What the third phase is doing is it's actually saying for each one of these that comes back, if any of them fail, go through. But also, in sort of deference to the idea that I don't want to try to destroy my infrastructure all at one stroke, the idea here is it only ever tries to fix one at a time. And the idea here is that if you have an ordered list, if the first one in your list that is not working stays broken, it will continue to try to fix the same one. It can't continue on and destroy your infrastructure. So things like that, things like adding pauses, I think they're very important for adding initial faith. One of the stories I have is I used to work at a hedge fund, and they were one of the early pioneers in automated trading before high frequency. And the first time they actually did that, the first time they hooked up a computer to a trading platform, they had an intern sit in front of it. And his job for the first few weeks of the system was to hit check every time unless someone shouted at him that the sky was falling. Because you want to make sure that a person can deal with these things. And you want to slow it down to the point where you can actually see what's happening. So if some of the smartest people I've ever met can do that, it's good enough for me. Now, what's happened here is while we're talking, while I'm telling you that story, it's gone and resolved. Can we actually see that? Yeah, look, the result's up here. And look, this has returned. We're all back good again. It's automatically resolved it by basically going through the process that I talked about. And you can see some of the thoughts I went into lead to this being okay for a demo. For your own infrastructure, you'd probably want to add a lot more checks. You'd probably want to give it a lot more time to bake. But this is the idea, and it's actually pretty cool because it took us a long time to feel like we could do this sort of thing. And now we're using it more and more. And again, this will be free for you to try out. You might want to get rid of the code and decide it's horrible. Do it yourself. Find your own ways. Hook it up to your own system. I would love pull requests. Once it's public, I'll try to publicize that. But do I have any questions? Anyone want to ask what's going on? How did I ever think about this? It's a terrible idea. It's a wonderful idea. Please, let me know. Anyone? Really? I'm going to put the elevator music on. Because we're pretty much done here if that's it, but I would love to know if anyone has any thoughts, questions, clarifications. AppOptics, yeah, right. That is a platform that does metrics, that does alerting, and also does a certain amount of APM, that's tracing and distributed tracing. And so there are different ways you can do alerts. I mean, I'm not really here to show the product, though of course that's why I'm here. But if you want to know more about it, feel free to come up and talk to me. I think it's a really great system, but I'm talking about one thing, not the other. No, you know what? In this case, it's documented in the repo, and I'm so sorry. I really wanted the repo to be out there so people could just look at it. The way this is structured is that Salt is actually doing that from the engine. So the configuration inside of the engine configuration includes a parameter for what Salt's current API does, and they change this all the time, but basically they give you a webhook, and that webhook is pre-configured so that you just tell it what rooms to go to. So you don't have to invite it or anything. When you create this webhook, it says, alert these channels. And the idea is that Slack does its interpolation of whatever messages there are. So you can put in emoji, you can put in links to an image, you can put in your own memes, whatever it is you feel best expresses your group's way of working. And the one detail that I thought was interesting for this that we did fun is that webhook URL can be passed down to the runners. So if you have a longer running thing that you need, you can pass that to the runner. The runner can notify you on a schedule, and tell you what you need to know. There's one thing I missed actually. That thank you for mentioning that. One thing is that when we do these alerts, we like to link to our logs. So this actually shows us, hey, if it's not going to be that long or we want to track back to it, we have a search for the salt master and we can see what's going on here. This can be any search. This is just the default search saying go to the salt master host, because this is my own demo account with these 4 hosts. But normally we have it linked to something that like either filters out the default noise, or specifically links to this is an event ID, so we can search for that event ID. It interpolates to some extent. This is just our info level stuff of, hey, I'm checking out SQS again, which isn't that interesting. So yeah, so we basically support that, and I also, in the documentation, say if you're gonna write a runner, make that an optional argument so you can run it from the command line without having to cut and paste a Slack URL. Any other question? And thanks for that question. Thanks for getting it going. What's the next one? One more? Anyone? 2? Okay, 3? Okay, so, oh, yeah, go ahead. Sure, so the idea with, the question is, and I forgot to repeat your question, the earlier question was, because in the recording no one will know what you said. The question was whether the platform took care of notifying Slack, and it doesn't. That was the answer. This question is, can I talk a little more about why SQS is being used? And the reason is that we are a SaaS platform, and so we want to make sure that you don't have to, in order to get the benefit of this, provide us with an open to the internet webhook from some rando, right? So without having to, we're in AWS, we don't think it's a great advantage for us to do something like stick an elastic IP on this so you know where it's coming from, because that kind of limits our abilities to do things like move data centers, et cetera, et cetera. So what we want to be able to do is just say, hey, here's a mechanism that you provide to us. We already have SNS-based alerting, and so AWS supports subscribing an SNS topic to an SQS queue pretty reliably, right? And so the idea is that if we use that mechanism, it's built into the product. Most people are okay with exposing an SQS queue because it's what it is, and you know who it's coming from if you give us the key. Any more questions? So this is what I'm going to ask. Thank you for asking that. Really not more. Okay. How many of you would be interested in something like this? And I'm not saying committed to it, but I'm just saying in principle, does this scratch the itch of, oh yeah, maybe we'd want to do something like that or try it out or see if it would work? All right, that's really good to hear. So I'm going to, I've got my company email in the first slide, and I'm happy to talk with anyone after this. But if there are no more questions, and we did start a little late, and there is the final Ask the Engineer session coming up, I'm totally happy to let everyone get on their way, and I really appreciate your attendance. And I'm here for questions if there's anything you want to ask one-on-one that you might not have wanted to shout out to the crowd. All right? Well, thank you very much.